Welcome to this tutorial. I want to show you tips on how to create your file using SolidCAM, how to create a part program using SolidCAM. But for today, we want to use 3D model. How to use a 3D model? Then we do pocket without cutting this part. How to use pocket without cutting this part, which is inside pocket, meaning without cutting this. At the same time, we also use tapping. How do you use tapping for this part? So for our tabs, we have separated the program here. We are using M7 by 1. And then that is what our thread we're going to use. That is M7 by 1. Then I've separated my part. That is, this is the target. The whole of this is target. And then this is the stock. I want to create a stock. Let me create a stock. Maybe from this part, I'm able to create a stock. So come to features, extrude. Extrude. So here I want to put a fillet, I want to do facing of 2. Then for the stock, because I want to use 3D model, ensure to uncheck this part. Uncheck this part. Then for the lower one, I can say maybe I want to use 12. And this is up to surface. Up to surface. Check here up to surface. Pick this face. Or you can measure, check the dimensions you want. This is 28, so you can use blind and then you put 28. For the purpose of safety, you can put 29. Okay, then I've not checked this. Then click OK. I'm going to use the 3D model as my stock. So I can save this one, I can rename this one as stock. How do you rename it? Just click on it and press F2 to name it. So then, because it's a stock, change this one to be transparent. We're able to see what is inside. So this is our stock, and this is our target. So I've separated my target. How do I do it? You just hold on, select the first part, hold on Shift, then press the last part. Then right click, go to Add to New Folder, like that. This becomes very easy. So we have our target, and then we have our stock. Also in the solids, it comes here, we have our target, and then we have our stock. As simple as that. So how do we do it? Okay, so go to options here, add-ins, ensure that you activate your SolidCAM. I'm using SolidCAM 2024, make sure you activate it. I want to show you the power of SolidCAM 2024, how it is used. So go to SolidCAM part, you can use this part, or you can go to tools, then SolidCAM new milling. So we are now to use milling. They save because we have made some changes for this part. I want to show you the power of SolidCAM 224. How you can do pocket inside without cutting this part. Okay. Then internal. Okay. The first thing is setup. So the setup involves taking selecting the machine. So I'm using the normal 3-axis milling machine. The next part is the coordinate system. That is part origin, where you're going to set your origin. So click on the coordinate system, and then you define it. There are many ways you can do it. So you can click, for example, if I want to make my origin at the center, I can click this face, and then I say I pick this top center of the model box, and then I click on this top face. It will detect automatically, then it puts. Normally, in case it puts maybe the wrong one you don't want, you flip. You have this option to flip. For example, if I flip around Z, you see it how it changes? How it changes, Control 5 can show you. I want my axis to be like this, Control 7. If I don't want, I just click flip Z, like this. You see? That is the beauty, just flip, then it goes where you want. So which means the longest side is x-axis, the shortest side is y-axis. Then you click on OK. Proceed. And then the main objective is we are using 3D model. That's why I made this stock. And then I didn't combine or didn't merge. Then I said change it to transparent. So I want to show you how we can use 3D model. And then we do pocket without cutting this inner part. Okay. So just accept, because we are using one coordinate system. Accept where it is. We have defined our coordinate system. Let's go to stock now. Define our stock. So here, change here, under define by, change to 3D model. then pick on this top face, this face, the transparent part. If you want to confirm that is the solid, the target, click sorry, the stock, click on the show, then you see this is the stock, the stock, the material which has only been cut. Then you click OK. Also confirm that the target is picked. So click here target, and then click here show, so that you're able to show that whatever you have selected is the right target. Because you may have picked the wrong target. This is the target we want to cut. Okay, then click OK. Also, the SolidCAM 224 has this power. You when you click on this recognize, it is able to recognize the features that should be cut, and this makes work easier. This makes work easier. Okay, so it has recognized all these features. So click OK. And then for this purpose of tapping, then we click OK because we have done our setup. I don't want to pick these others. I'll show you the later. For the purpose of this tapping, it is M7 by 1. So our drill will make a drill hole of 37. The maximum diameter is 7. Then minus 1, so you get 6. So which means we need to make a hole of diameter 6. A whole of them are 6, but I hope this is, I'll check if this is okay, so that we don't interfere with this. So let's go to operations. First of all, because I put extra material, if you click one, you see this one from the origin, I have a lot of material above, so I want to remove that material by doing what? By facing. The first operation is to do facing. Go to face. On your face, the geometry, you can use the part base geometry, or you can use the stock base geometry. For the purpose, because we want to use stock to face the stock, click on stock face geometry, then go to tool, click here, select the tool. The face is, this is a tool, double click on this, then you can either click F1 on this, F1, F2, you can say maybe you can customize your tool. Face mill, I'm using face mill the meta 40. Okay, you can change all this depending on the tool you want. You have all the parameters. Check on the parameters of tool you have for the face mill, then you update that. Then for this, I want to do finishing, then milling here. Coolant, machine coolant. So the machine coolant is not active for this part. So what we will use is we will write the coolant manually. We'll put the coolant manually. But if you are using the hole through, you can pick hole through a tool because maybe you have a hole through coolant. You click OK. Yes, go to levels. I want to use a simplest so that it doesn't go further. The upper level, you can click on this upper level. You pick on the level you want the Z axis to be. Then depth, by default, it has detected that there's extra material 2 mm from the stock you have made. So I don't want to change. Step down, then use the smallest for the purpose of simulation. But if you are cutting, I'd use 1 mm or 2 mm because I'm using carbide. Then I like using hatch. Let me use hatch. The percentage, let me use 60% for the purpose of showing it. And then you can use Z. Zigzag. If I use constant Z, which means it will cut all the depths from one point until it reaches the depth required, then it goes to the next point. So let me not check this. I can use, let me use even hatch. Sorry, contour. Contour is okay. Then you can say here that to make sure it's smooth. Technology link. You can use one leave by default. Then calculate. Then after calculating, let's see how it will be cutting. Just a simple simulation, for a quick way to understand how the tool will be approaching and how the tool will be cutting your part. Okay, so this is facing. Okay, so you see these are the tool parts. So click on this, simulate. You can do this 3D model. You can click. You can click on the face. It is updating the target. You can click on this face, then you run your program. This facing, doing facing to remove the extra material. As simple as that. Then once you finish, we want to go to next. operation, drilling. We have drilling and drill recognition. You can use either of them you want. Let me use drilling to make those holes, then a pocket, and then from there I'll do tapping. So click new, then you can click on the point you want. Maybe if this is the hole, you can pick on this hole, for example. That's the hole I want. That's the hole I want. You can pick these holes, for example. Those are the holes I want. So how many holes? These are the 5 holes. And then I can also put this, that one. Then it has, you can pick inside the hole, or you can pick a point that makes the hole, or the curve that makes the hole. If I pick on this curve, it detects. If I pick on this face, it detects. So you have 6 holes, and these are their points, or their parameters. Okay, so what do I do? Just click OK. Come to tools, select tool. I'm assuming I've done my standard drill, so procedurally you should do a standard drill, or I can do standard drill first. So click on standard drill. Standard drill, I will show you. So the standard drill, I'm using standard drill 5. So all these parameters I can check this one because I'm not doing finishing. And then I can say here now tool standard drill, because you are now doing a standard drill. Then level, I can also put 5. Don't want to go further. Depth, for standard drill, don't go deeper. Because I've done facing, the depth can be changed to that one to prevent taking a lot of time. Then for safety, I can put 1 so to start away. The depth is, I can put 5 of it. That's the depth, full depth, like that. Technology can come here, advanced, sure, come to advanced, maybe use this pattern. Then cycle, I'm using D3, data, can put here 2, 1, 1. Okay, and then can here do calculate. So do a simulation. I want to show you solid verify how we're going to be doing our tab standard drill before you do our drilling, and minimize this like this. Then this, you see, that's the tapping. Okay, then another way of doing this is right click on this, because instead of adding, then copy, right click again, come here, right here, click here, paste, then click and check this, click on this one, click edit. First way of doing is come to your geometry same tool, so change now and check this, then go to select your tool because you're now doing drilling, then click on here, this one, the drilling. Then we are using 6 because we are using want to put M 7 by 1, so our hole is 6. Then the depth is okay, so I can put the hole, a depth should be 30. This one you can change this one to 35 like this. Then parameters, and check this, this is 500 like that. Okay, then levels, now we are starting from this point, we check also. Then I'm also starting away by 1 or by 0.5, 0.2 for the purpose of safety. Depth, I can come here, I can pick the lower face like this. Okay, then because of the taper, I can put -3, it goes deeper, -3. Technology can do that. Here, come here, GA3, quick drilling, I can put here 3 for the purpose of doing the faster. Calculate. Okay, that is, and then check, also check your holes. So this hole is diameter 13. So if I don't want to do a drilling with diameter 13, I can again drill with diameter. So this is, let me also check this one, so that I don't want to drill. So this is diameter 10. So I can use diameter 10 from diameter 6. So let me go to copy this, paste, then edit this one, so I can change the geometry now, a new geometry, because I'm using a new path. This one I've finished, so I'll go to this one. I pick this inner and this inner. There are only 2 holes. I want to, this is 13, this is 13, this is 10. So I want to use a bit of 10. Go to tool, select. It's not standard drill, remember. So So you're using, I'll check that drill. Then we're using 10 after from 6, 10, so it's okay. I can put this one as maybe parameter, my tool is maybe 35. This is 40. All of this, okay. I can check this, okay. For now, then go to levels, the upper level. You're using this upper level, same. Pocket depth, you're using 31, so you can click depth, then you pick the depth here. This is our depth, okay. I want also to exit by -3, okay. Then full depth technology, I'm using PEC, so I can use PEC. Then I change here data, I can put here 4, okay. Then calculate like that. So you have this. Then I can go to now another operations here. Come to pocket. Want to do pocket? For this pocket, I can start with this inner one first. Pocket. So you see these ones. So I want to use the first one. So this one feature. Then ensure that you click the faces. So here, click on this face. So the face is here. This is the face you want to pocket. That's why I wanted us to pick this. So this one doesn't cut. That's the beauty of SolidCAM 2024. So I'm using this option. Then come to tool. Take your tool. Also ensure that you check the corner radius. Come here, measure all this radius. So the radius here, we want to check and measure the radius. For example, measure this radius is 5. So you can use any middle of 4, 8 or 8 or 10. So let me come here, pick end mill, double click on this end mill. I want to use end mill of 10 or 8. Let me use 8 for the purpose of that. This one 24, this 35, this is 40. Okay, so you can put the parameters and check this if you want. Let me leave the way it is for now. For now, I want to leave by default, but ensure you put the correct cutting parameters so that it matches to the material you are cutting. Okay, the levels, you can pick the levels. It has detected, you see now the beauty of this SolidCAM 24, it detects the level. Then pocket here, I want to use 1 millimeter depth, or for the purpose of the implementation, they will use 0.5. Technology, ensure that I'm using 60, this is 70, okay. I don't want to leave any material on this. Contour, or this contour here, you can ensure that it's smooth. Ensure that you do tool optimization. It doesn't take many parts. Then for linking, you can do helical or you can do vertical like that, or you can do helical. Let me just put helical for now. Then calculate. Calculate. We want to do simulation. We see how if it will cut that region or not. Go to simulation. If it will cut or not, then a solid simulation. Will it cut that region or not? So we want to see. That's the beauty of SolidCAM 2024. You can put this isometric like this. Then let me increase the speed. Cut. Helical. You see, it doesn't cut the inner part. It doesn't cut the inner part. That is the beauty of SolidCAM 2024 using pocket milling, where you just pick the face you want to cut. So you see, it doesn't cut that part. This part, the inner part, it doesn't cut the inner part. And that's the beauty of SolidCAM. Yes. Also here, it is showing the data, how it's cutting and the depth. So up here, Z is the depth. So you should go up to 24. 24. That is was 20. It was 20. So it should go up to 20, then it stops. And I'm using 12.5. Now see, it is on 20. Now it's finishing. Yes, it has finished. Then it goes up to 25 at the safety. Okay, that is how you program your tool. You see, I can even change here 5 so it doesn't take a lot of time. Then here I can the pocket depth is already detected from the top surface because it is picking from the top face. Okay, that is what we have. This one, last pocket. Last pocket. I want to add the last pocket here. Come to operation again, pocket. you want to pocket this one first, because they have a material here. I want to use the same tool for this pocket, or you can also use the face. You can also click this face, then click inside here, then pick the face you want. That face, it is here. Go to tool. We are picking the same tool. Let's use the same tool, number 8. Let me use number 8, the meter 8, sorry, number 5, the meter 8. Okay, then we're using the same tool. Then we give the parameters here. I'm using the same tool, so I didn't want to change. Go to levels and make sure that I'm using 5 equals step down. The depth is 7, and it does. I don't want to use full depth. I want to use this 0.5. No problem for this part of the demonstration. But if it's the final part, I don't use 0.5. Then contour, as I said here, I want to use smooth. Sure to do tool optimization. Then you're using climb, milling, then link. You can also use this, or you change how you're going to approach. And say okay automatically because of the tool, no problem. Then let me do a simulation first, because it has given me an warning because of the tool radius. Maybe tool it may be leaving a lot of material, so that I change the tool for the purpose of making the work look nice and professional. Okay, so let me do this one first. I want to see. Then you come here, rest material. You check on the rest material if there's material that has been left on that part. Yeah, it's okay. So there are other areas you see that the reddish, which means the material has been not cut. So we want to do remaining part. Okay. So what do we do now? Okay, let's do the final pocket. You can copy the program or just add a new pocket, no problem. Final pocket here, because it was 13, I've done 10, so I can use end middle of 8 to do pocket to finish this part. Okay, so I can now pick this. There are two main options. The first one, this is this one. Now I can use this. Then I can click new. I can also pick a geometry. Very easy for this part. Pick this edge, then say okay. Then come this. Take the tool. Go to tool. Select your tool. Yeah, I'm using the same end middle of 8. End middle of 8. Okay. Then go to levels. The levels I want to use 5 here. Then upper level, I want to make sure that these are my upper level. I want to minimize. Then depth, I want to change my depth here, because this goes through. I want to pick this as my depth, or pick this face as my depth for the purpose of being safety. Then I can say if I want to go through, I can go through. If I want to put 1, it leaves a 1 millimeter material. If I put -1, it goes all the way to cut the 1 millimeter excess. Okay, link this one. As I said, I'm using 8 contour. I want to minimize my tool optimization like this. Then calculate. Yes, for the link or whatever, I've done it separately. I've just left this one for the purpose of demonstration. Do a simulation. Say yes. Check if it's okay. Solid verify. You can put it to isometric. Here, you just click here isometric. Click on this face. Run. Does your pocket very fast. It does your pocket very fast, like that. Okay. Control 7. Exit. Then a last option. Second last option operation is we have not done is come here operation. Now you do tapping. Tapping. How do you do tapping? How do you do tapping? Okay, come to thread milling. Thread milling. You want to do tapping now. Then new geometry. You want to put a new geometry. You can just put a hole, a point. Maybe you can pick a point. You see this part. You see this something comes here. It's called selection filter. So you come here, select selection filter, so that you don't want to see it again. You want to check here, then you close it like that. Come to this point. You can pick this point. I had put my symbol points for the purpose of making it concentric. Okay, so those are the holes I want to do tapping. Okay, And then come to a tool, select your tool. Now here when you're selecting a tool, you're using a tap tool, because here I'm using thread milling. So for thread milling, you can you have thread tap, taper, and this. So double click on this one, and then change here the tool to tap. You have thread mill, change the tool, because now we have to do tapping. Change to tap. So I have to use tap. Then my pitch is 1. My thread diameter, the thread diameter was it 6? Thread diameter, that was, yeah, it was 7. So that is M7 by 1. Then tip diameter, and by default shoulder diameter 7. So I can put this one, let me 6. This is sorry, 7, 7, 7, and then this cutting length, the cutting length, that is CL. The cutting length should go up to 29 to 29, 30. Yeah, 30. This one should be 30. That is shoulder length. Shoulder length, that is 50. My tap is 50. It's a length of 50. Total is 75. So this one was 60. It was this one 60. Sorry, 60. This is 75. Then number of flutes here, there are 4. So we update these parameters. Then here, the spindle speed, I'm using 714.5. Here I'm using spindle speed of 475. So you need to know how to calculate cutting speed. The VC over that is 1000 divided by pi d, and then this one you take the feet rate per millimeter, that is millimeter per minute, the feet rate times your pitch, Let's see, 475 divided by the pitch, which is 1. Yeah, so this one pitch is 1. You see, I'm using the wrong value for this part. So 15, that is 1000. 1000 divided by 15. It is 15 times 7, you get 105. Then 50, what is 1000 divided by 105? I'll get divided by, that is 15. Yeah, so I'll get 475. That is the opposite. 475 by 475, because the pitch is 1, so it will be 1. So this one times the pitch of 1, I get this. So that's okay. Then I'll come here, incorrect tool type, right? Okay, yeah, I know this why I know this one. I put the wrong tool. Let me check. Maybe I have put the wrong parameters. Wrong parameters. So that, yeah. Incorrect tool. Current operation cannot work with this tool. I done thread milling. Why is it down thread milling? Save no. So suppose the tool here. Sorry, this is where I forgot. This is where I forgot, because we don't want to do thread milling for this. We want to do tapping. So for you to do tapping, you pick 2D drill. 2D drill. It will change to 2D drill, not what we had done. Sorry for that. Then the geometry will remain the same. Then here 2D drill. Then come to select the tool. That's why it just give me those errors. So the tool we are going to use is now for this tapping, because we want to do tapping. Tapping. Then for this tapping, here we are using a tap of M7. So you put M7 like that. The cutting length, as I said, is 32. This was 60, and then the tap is 75. 75 like this. Then the pitch, the number of flutes is 4. Then you come to this. That's where I was surprised. Why am I putting this 475? Also, I'm using 475. There's no finish here. Okay. Yeah, That's okay because the 3D milling is if we're doing milling, that is 3D milling. But this one is 2D drill, but we are using tapping. Level, that is, let me put this is 20. Then it is upper level, depth. Upper level is automatic, depth is 29. Then if you're going depth more than that, you can put maybe -1 to 30 for depth, like this. Technology, you check shortest distance, advanced, shortest distance. I'm use also distance by this. Advanced, I want to use, we have this type of peg and this. So let me use the first one. The first one is good. If you're using peg, you put the data. If you're using peg, sorry, peg, you put the data. But if you're using the first one, you don't put the data. So I'm using the first one, so I don't need to put the data. So it is not peg, it's the first one, sorry. And then you can calculate, say yes, yes, exit. Then the last operation is now what you call profile cutting. Let's go to profile, cutting, and then new geometry. You put this one, select this one as your contour. Okay, then tick here. Tool. I want to use the same tool for cutting others, so I don't put too many tools. That is in the middle of 8, unless it is broken. But if it's okay, you can use this in the middle of 8. Change. I didn't change the number of fields, I think, but there's no problem. I change this on 5. Upper level, pocket depth. I can cut if it is well secured, but not. You make sure that you leave a material on that side. Technology, show here the geometry, click here, Control 5. This cycle, it means the tool is inside the material, so it will cut material wrongly. So what you do is change here, then click here right. The tool geometry is outside, so it's okay. This is called tool composition using G41. Okay, Control 7 here, Control 7. Then I want to do equal roughing and finishing. So I want to do roughing of 1, number finish of 1, wall, the middle, the material on the wall. I can use zigzag, yeah, no problem, rounded. So path is rounded or sharp. So I want when it's exiting around the corner, normally you like using rounded geometry or tool approach. Then for this one, let me leave by default, calculate, and then exit. Okay, so you have all these operations. So you hold down, select all of them, or pick this one like this, right click, then do this one called SolidCAM simulator. You want to see what it gives us. You can change these operations to turning heavy part, new theme. You can put on a new theme if you want, or you can do theme editor. All this is under SolidCAM. SolidCAM 2024. You want to show maybe target over stock, you can show this performance. In case you want to show all this, you can ensure you can check them. You can also check stop playback on crash. In case it crashes, it stops. It detects and then it stops. You can also put record material, record removed material. You can also record like that. You can show the tool part. You can show all this. Okay, it will come there. So you can update all these parameters. By default, I'm using Solid Verify. Then if I click on this one, I can then this is speed. I can increase the speed or reduce the speed for simulation. Let me reduce the speed for the purpose of doing simulation. Then you click run. Let me reduce the speed a little bit for the purpose of showing what is happening. Yes. So these are the operations. Now that is center drilling, then tapping. Sorry, that's not drilling. Tapping or only 4. Then it's doing the pocket, in a pocket. Can increase this speed. Then increase the speed. See? or you, in case you want to do, you pause this one before you change to other, example heavy part, then you run. You see, you can pause, you change the simulation type you want, or this 3D simulation. You can pause, you change the simulation you want, and if you run, click run, it updates. So this is what it is doing using. It has already done our tapping, pocket, and these are the tool parts. So you're able to do a simple simulation to see what it will give you. Then you see here, warning, collisions detected. So it gives you that this collision has been detected in your program, which means when it's approaching, there's somewhere it is approaching wrong. So this one helps you to go into a program and change either the tool diameter you use is wrong, or the tool approach. That's why I said I was using the helical, but didn't change the parameter of the helical. So maybe when it's approaching helical, it is knocking somewhere, and it will not give you the accurate product. So this simulation helps you to understand how the tool is cutting and where the errors are. You see, even here, you see now here, it is showing you how it's cutting, which kind of program. So you have many programs by the color, So this advanced this SolidCAM simulator is good to help you detect errors. The other one will not show you this error, but this one can show you these errors. You see, it is telling you hover the crash makers from the start of the crash to whatever. So it shows you when you hover over it, over this part, these are the programs. The first program, second, third, the fourth, the fifth by the color, the sixth, and the last. So it tells you each of them. When you hover over this, you see when you hover over this, also it shows you how the tool is approaching. By default, you're able to understand maybe where the error is. That's why it's telling you, you go to the tool where it is crashing, or the tool part where it's crashing, and then you're able to detect the program. And for me, to know that somewhere here is a problem, here is a problem, because it is maybe crashing or the tool diameter is wrong. So this SolidCAM simulator for the SolidCAM 2024 and above is advanced, helping you detect the errors when you do simulation. At the same time, it shows you the material that is remaining. That's why I done most of the setup here. This theme editor to put on some switches so that it can give me a guideline on how to identify the problems and how to rectify the problems. You can also do the other simulator. You have this type of simulation, you have this normal and this normal. This is for the advanced, for the new SolidCAM 2024 and above. I think from 2021 and above, you can find this SolidCAM simulator. You can also do the normal one. We see if the normal one can give you any errors or not. So the normal simulator will give you the errors. Maybe let's say check if it can detect any crash. If it can, let me see. It is now doing these operations, but there is nowhere it's telling us that it has detected this kind of errors. I can also say that show the colors for the purpose of knowing which kind of operation it has done. Let me exit this one first, okay? And then I show you again. Run this, do a simulation, solid verify, okay? For the purpose will it help us to know the errors or not? Click on this face, then click here, show the colors, run this. So the first that's facing, second is, so show the colors, you see? You can click here colors, you can update all these colors you want. For example, kind of update all these colors you want. If it is define, you can pick all these colors you want, add or customize all these colors. So when you click this one, you're able to use these colors as you want. See? When it says show the colors, it gives you the color where it is cutting. Also, you want to show here, another feature you can show here is the tool change. You can also show maybe the feed change. Then you can also detect, yeah, you see it has detected feed change. Yeah, I'm saying stop when it changes the feed or stop when it changes the tool. So here there's a problem on this part, or you can do rapid movement, all this. If you check on this one, it is detecting where the errors are. So you have to play again. You see, I had said stop or when it changes the feed. So I don't want to change the feed. I had said stop when it changes the feed. So if you say stop when it changes the feed, automatically stops where the feed changes. Or it stops where you change the tool to help me know how the tool is approaching. And even look closely, somewhere here, you see this color, it is somewhere wrong on this round part, simply because of my tool approach. So this one will help me to know how I'm going to solve the problem on the part when I'm cutting. I can also synchronize the point. You see, if I click stop when the tool change, it will stop like that. So also this one can help you. When you click on this one, you can stop on each of the part. But it won't give you a warning as say, because this one doesn't give you a warning. But the other may give you a warning when it is cutting. Yes? So let's see. I've just increased the speed for the purpose of that. But in short, for the purpose of reducing the time, the inner one you should use a bigger tool. So don't use the smaller tool for the purpose of pocketing because you may be wasting your program. Also here when it's doing the cutting, how it's approaching is wrong. So as a programmer, all these are the errors you need to identify and sort before you transfer the program into the machine. That's why when I do simulation is good. And I'm able to even to check my my part is. So those are the key points you need to understand how you are programming to help you maneuver around the program, to help you maneuver around like error detection, then rectifying the errors before you transfer. Okay, last part is now let's generate a program the way it is. But I'm not generating this program to put on a machine because I have not rectified the errors. I don't want to show you how to rectify the errors on this part, because this part for demonstration. In case you want to understand how to rectify the errors, you can book for classes. We show you in our workshop. We are located in Lunga Lunga, Nairobi. We show you how to do this so that you're able to learn more on industrial part. Okay, once you program this, you can generate the program. You can select all this. You want to combine. They come here, G code, generate program. I want to say maybe this is for advanced machines. You don't need to put all something as a file name. For GSK machine and that is a HNC machines or surgery star. For this one, like Siemens, you just put any name. My program will accept as long as you have not put the reserved names for machine. Okay. So let it open the program. I will show you where the tap program is. Because my main aim was tapping. My main aim was tapping. I want to see how the tapping program will look like when it opens up the part program. So all this is what we have done. Yeah, this is the part program is now opening. This is the part program. So it has also put all the tools we have used. Tool number 1, 2, 3, 4, 5, and 6. It has arranged. Tool number 1, diameter is 40, that's first mill. Second is diameter is 5, that's the center drill. The third is diameter 6, that's drilling. Diameter is 10, drilling. End mill of 8, and this is so you can also edit. You can say this is your first mill. Maybe somebody, if you are sending the program, somebody able to understand this is the center drill. Center drill. If you're sending the program to a workshop, somebody can understand this is drilling or drill bit. This is a drill bit. This is a end mill, and this is this was our tapping. This was our tapping or tap. That's M7. You can just put M7 by 1. M7 by 1. Okay. And then I can remove this. In case I don't want this one to show on my program, I can do this. If you put a semicolon behind, it means the machine will not read that program. Let me expand it further for the purpose of explaining. I can click this to be back. If I'm using Siemens machine, I can also put here G291, for example, Siemens 291, Siemens 2808. You want to convert this program to ISO, I can use G291. Okay, this one, if I put semicolon behind, it means I don't want the machine to read this program. It should skip this. So the first one is facing, so it is doing facing. I can change here, then write facing. This is the headers. These are our headers. We call them headers. If I want to use this tool combination, I can use it. But if I don't want, I can just jump it. Maybe I'll say G00. Maybe my Z is 120. And then I put this one semicolon. This one can be, I will renumber them. So don't worry. I will renumber them. This is editing the program. I'll show you how to edit the program. So you don't make an error when you are putting the program on the machine. Then I put a semicolon behind. This is fast drilling. You see, I can put this fast drilling, and I was using G83. This is the syntax for G83. You see how it is. If you put this code in your machine, if your machine doesn't understand the positive one, you use minus. You put minus. If it understands, you leave the way it is. Okay. For the purpose of those who are using machine but maybe requires syntax, then again G83 again for this part. Then we have another one here, G83, another one here, another drilling. Then this is pocket using face. Where is there's a program I wanted to check for. Which one was that? Have I jumped it? It's a program I want to check for tapping. Don't know if it has generated the program for tapping or not. I'll see. Let me check for tapping. Should be using G84. We have that, drill 1, drill 2, pocket, I think arrangement of the program. We'll see. Let me see. Because that's what I wanted to check for this case. Tapping program. Let's go down. That's big. Maybe I'll check if I've done tapping or not. I'll generate again for tapping. Maybe I didn't select for tapping, but it should be there. And that's the program I wanted to check the code for tapping. Okay. So you can use find, but I want to go direct. No problem. Don't worry with this. So this is a combined program. All this where you see these different colors that's put all the program. Like the red is not cutting, just approaching. The green one, the red one is retracting. Then the green one is G01. Then the others are G02. So you need to understand how the program works. Why does it put the colors? That is the power of CAM softwares or CAM package. Each package may put syntax differently. Okay, for SolidCAM, make sure that this value you change it. In case you don't want to need to put this, in case you don't want to put this one, you can uncheck this. You put semicolon behind. Maybe you don't want this to read. This one is homing the machine, but if you don't want it to, you put that semicolon behind. Okay, but if you want it, you leave the way it is. So this is another facing. This is profile. This the last one is profile. Right? Profile. This is what I wanted. So this is the program I wanted to show you. This is for tapping. Let me change the name here. Tapping. This is the program I wanted. So this tapping, it has four holes. First hole, second, third, fourth. First hole, second, third, fourth. I'm using G54. Then here, I'm missing G. So I can put Q4. Q4. Sometimes when it regenerates, it misses putting it. Then you can also put this one fitted maybe yeah, 475 is okay because I did my calculations, okay? So the tool will come to this position, X first hole at this point. These are the first hole for X. That's the first hole. X at this point and Y at this point. Then second hole, it goes to X this, maintaining Y. Third hole, it maintains X, it changes to Y. Then fourth hole, it maintains X and changes to X. It maintains Y, X, and then Y, then it changes to X. Then also this, as I said, you can put G00, Z120, then again Z50, small approach, Z10, Z5 before it starts. So this is just, this is, you can put Z30, you see, then it goes Z20 like that. So this is just an approach, maybe Z10, Z5, that. So this is just an approach. I'm putting approach. So this is the program for tapping. This program for tapping. This 17 I'm using XY. G90 I'm using absolute positioning. G40 this is ensure that you cancel any tool composition. Then G80 ensure that you cancel any cane cycle that was used. Then G00 using G00 for purpose of approaching. This is the program we have done. We can come to maybe this one part, backplot. We want to see how does it do the backplot. This we want to see how it will also do if it has errors. I'm using Simco. I want to also do a simulation using Simco if it may have any error on Simco. Okay, so I can click on this part. So this is the part here I have. I'm able to see that this corner, and this corner. So let me see if I run it. So facing, it's doing facing. Let me pan this to put somewhere here. It is doing facing. The answer chini, I've started out there. So it is doing facing. Let me run it faster to check the program. Then it comes to the pocket, the upper pocket. So I'm doing all simulation checking, going to check the program as you're able to see. Then every time you see using the red codes here, this is where it is approaching, not cutting. That is retracting and approaching, retracting and approaching. So this one, it is scanning the program, checking the program if the program is okay. In case of any error, it can also show me the errors. And I can also put those changes here. I don't want to put those settings there because this is for demonstration. In case you want to understand how to use also Simco, you can come to a class will show you how to demonstrate on this. This is now a purpose of automating programming. So you can check all those parameters because you are dealing with a machine which is very expensive. The tool is very expensive. If you miss one, you have affected the output. The client, you are delayed the client. You have affected the machine. You have affected the tools, and you need to buy more tools. You need to buy material, and you need to buy time so the client can be satisfied with the time limit you have given. So when you're programming, you take time, you take caution, so that you don't just break the tool, you don't just break the workpiece, and you don't injure the neighbor, or you don't injure the operator next to you, or you don't injure anyone, or endanger somebody around the workshop. So programming is key, but safety is important. So this is scanning the program, checking if it's okay, all this part. So as a programmer, one, you need to understand CAD design, computer aided design, understand how you design. Second, you need to understand computer aided manufacturing. Any software that is helping you to do manufacturing, to automate manufacturing. Because when you use those softwares, you're able to generate what you call G and M code. So whatever you are seeing here is what you call G and M code, preparatory and miscellaneous functions. Because you need to understand how this language operates, how this language are used to control the tool movement or to control the machine table movement. So the CNC is just a computer numerical control where you're using coded instruction. These are codes, coded instructions to control how the table is moving, how the tool is moving to shape the part you want, to shape the desired stock, shape the stock into desired part product or desired output. So those all these parts are interrelated. So you have many softwares for CAM like SolidCAM, MasterCAM, Fusion 360, InventorCAM, Esprit, HSM CAM, EdgeCAM. There are so many of them. We have also different softwares for design: SolidWorks, Fusion 360, Inventor, Edge. We have called Solid Edge. We have Siemens NX. We have Clio PTC. We have AutoCAD. So it depends on which software you want to use. Most cases for manufacturing software use the feature-based design or parametric design softwares. For construction purposes, you can use other softwares like AutoCAD, ArchiCAD, maybe ArchiCAD, all of them. For CNC, there are different controllers. We have Siemens controller, we have Fanuc controller, GSK, HNC, Fargo, Mitsubishi. There are so many of them that you can use. So the CNC may be either for solid machining or for laser, that is sheet metal, or for router, for woodwork, or other 3D printing, or plasma cutting, or rubber cutting. So it depends on which kind of CNC, but the codes are the same. When you're programming, the codes are the same, but when you're programming, the method of programming may be different. Other softwares like we are using laser, CNC laser, or CNC plasma, you may use using software to slice the model, and then it gives you the code. If you are using 3D printing, also you may use a software that slices the model, then it gives the code. But for this one, you have to program it step by step. You have to understand the parameters. You have to understand the engineering perspective behind the machining, material compositions, tool compositions, tool approach, cutting parameters, coolant, and whatever. All those parameters, as a programmer, you need to understand how to maneuver around and check all these parameters. So this is what we have done for the purpose of demonstrating. And it has finished, and the learned program here is M30. You need to understand all this, the language, why M05, why M09. So this should be M09 or G, not G, should be M09 or G9. So this is G90. So you need to understand all these programs. In short, you need to understand all these programs and how to edit and maneuver. And in case your machine is Siemens, for example, you can come here, file, save as, and then you pick the controller depending on your machine. Depending on your machine. Here, these are the type of the file extension. For Siemens, normally it uses MPF and SPF, main part program file and sub-program file. For other programs, if you're doing normal machine, they could use n.nc or .text. So because I'm using Siemens, I can save as .mpf. Then I save the file. As simple as that. So this Simco can help you to edit the program and also have different machines. Like I said, it has Heidemann, Okma, Siemens, all those. If you're also doing simulation, backplot simulation, you can also check the kind of simulation. All of these are machines that you can use. There are so many of them you can use across. There are so many of them you can see. There are so many machines you can use for the purpose of cutting your part. So in case you have a query, you need to understand how to program this, to maneuver around these features, you can come to our workshop. We are located in Lungalunga, along Lungalunga Road, next to Patico, where we do our machining, contact machining, and industrial machining. Thank you for listening. Thank you for understanding what I've demonstrated. It may be of good help to you and the operator around the world. See you next time.